Hi children, good morning everyone. Today we are discussing about scattering of light. Scattering of light means it is a phenomenon of light. Whenever the light is entered in a particles, that particle can absorbed by the light. In the particle, some of the portion can be absorbed and some of the portion can be reflected. How can it is reflected and how can it is observed? So let we have to see in our textbook scattering of light. The interplay of light with objects around us gives rise to several spectacular phenomena in nature. The blue color of the sky, color of water in deep sea, the reddening of the sun at sunrise, and the sunset are some of the wonderful phenomena we are familiar with in the previous class. You have learned about the scattering of light by colloidal particles. The path of beam of light passing through a true solution is not visible. However, its path becomes visible through a colloidal solution where the size of a particle is relatively larger. That means when the particles are very important for this scattering of light. We have the VBGR, that means violet to red. In VBGR formation, the three colors of the orange, yellow, red have large wavelength. But in violet and blue color have a small wavelength. So the portion of the wavelength can be become say, if a wavelength is small, the reflecting area is very large. If wavelength is large, the reflecting area is very small. How it is, if you have to see this one, okay? See here, the scattering of light. We can observe a light is a phenomenon of light is absorbed by certain particles. One is small particle and another one is large particle. So the light have entered into a small particle or large particle. If light wavelength have two difference, one is large wavelength. This is a large wavelength, and another one is small wavelength. Small wavelength. So this is a small wavelength. So if the small particle is the light is entered into a small wavelength, the wavelength can be crossed by the small particle. So that means the light waves are entered into the small particle if the light waves are crossed by the particle. If it is large wavelength, the light waves are not crossed sometimes and sometimes crossed. So that means it's a jumping of light waves. Jumping off light waves. So that's why the small wavelength have a large reflections. The small wavelength have a large reflections. And small wavelength have a small reflections. That means the light reflections will be going on there. I don't understand. This is the large reflections and there is a light reflections will be there. So now what is scattering of light will be going on here? There is a two types of reflections. One is regular reflection, and another one is irregular reflection. Irregular reflection. If regular reflection means whenever the light is entered into the beam, it can get reflections all the sides of around the particle. All the sides of around the particle like this. So the light is entered, already we discussed from the lens in previous chapter. In previous sections already be going on there. So this is the all reflections. So the small wavelength can be have a large reflections. The small wavelength have a large reflections around the particle. If this is a regular reflections also. It is a regular reflections also. Now what is irregular reflection? Now irregular reflection means we have to use a certain wall. For example, wall we have taken. See here, this is a wall. When the light is entered into the wall, it can absorb by the light but not give the any side of reflections. But not give the any side of reflections. So, but here this is a non-regular reflections. Now, what is the scattering of light? The scattering of light means when the light is entered like this, it's a parallel beam of light. It's a parallel beam of light. If in front of the mirror, if the source is here, the source we can observe by this side of the mirror. The observer is in this side. See, this is a plane surface of the mirror. So that's why we have to see the image of the source is here. The source is here, the image can be observed by the here. So this is the scattering of light means when the parallel beam of light can be going on should be entered into the mirror. This is called a scattering of light. It's called a scattering of light, and the source can be absorbed by the smooth surface. This is called a regular reflection. Regular reflection. So we have to be used in regular smooth surface. We can absorb by the smooth mirror. We can observe by the smooth mirror. In non-regular reflections, we can observe by the optical particles. Optical particles. Clear? So the scattering of light is a phenomenon of light. When every light is entered on a particle, some of the parts of the light is absorbed and some of the parts of light is reflected. This reflection may be called as a scattering of light. I don't understand. Next, we have to go for next topic, Tyndall Effect. Tyndall Effect. In the textbook Tyndall Effect, the Earth atmosphere is a heterogeneous mixture of minute particles. These particles include smoke, tiny water droplets, suspended particles of dust and molecules of air. So these all are we have to call as dust particles. These all are we called as dust particles. So these dust particles are the including a mixture of atmosphere, that means in air. When a beam of light strikes such fine particles, the path of beam becomes visible. The light reaches us after being reflected, diffused by these particles. When the light is entered into all these dust particles, when the beam of light is the path of visible is changed. The path of visible is changed. So that's why the phenomenon of scattering of light by the colloidal particles gives rise to Tyndall effect. So Tyndall effect means the scattering of light by colloidal particles is called as Tyndall effect. That means a fine beam of sunlight enters a room containing a suspended particles of dust. The path of beam light to visible. It is due to the scattering of light. The scattering of light means it has making the different directions of the light. That means the phenomenon of change in direction of propagation of light caused by the large number of molecules such as smoke, tiny water droplets, suspended particles of the dust and molecules of air in the earth atmosphere. So it is called a scattering of light. Maybe how we can, depending upon it is maybe this phenomenon of the scattering of light by the colliding particles is known as Tyndall effect. So this is called a Tyndall effect. And see, the scattering of light makes the particles visible. Tyndall effect can also observed when sunlight passes through a canopy of dense forest. Hence, tiny water droplets in the mist scatter of light. When the sunlight is entered into the droplets of water, we observe a tiny particles of appear like this. The color of the scattered light depends upon the size of the scattering of particles. Let me observe in a small particles or large particles. So it has a very fine particle scatter mainly blue light, while particles of large scatter light of the longer wavelengths. Because of blue light has a small wavelength. blue light has a small wavelength. So in blue light we have to observe a large particles of reflections. When the red light has a large wavelengths. In that large wavelength we can observe a small reflections. So we can have the size of the scattering particles also large is enough. Then the scattering light may have even appeared white. White means because of the how a light is entered into the yellow, red, orange, they have to suspend of your dot particles, that means dust particles. We can observe the light is white. Are you understand? See the next topic. Why is the color of the clear sky blue? See, the molecules of air and other fine particles in the atmosphere have size smaller than the wavelength of the visible light. They are more effective in scattering light of shorter wavelengths at a blue end, the light of longer wavelengths at a red end. So, the red light has a wavelength about 1.8 times greater than the blue light. So that's why when sunlight passes through the atmosphere, the fine particles in air scatter the blue color more strongly than red. The scattered blue light enters in our eyes. If the earth had no atmosphere, there would not have been any scattering. Then the sky would have looked dark. The sky appears dark to passengers flying at very high altitudes, as scattering is not prominent at such heights. That means already in previous we have to discuss a large particles or small particles have a the wavelength maybe have a small, that means in blue color the wavelength is very small, so that's why the reflections are more. When the reflections are more, it appears blue color. That means due to atmospheric reflections in atmosphere, so many dust particles and dust particles, tiny particles are should be going on there. So all these particles, when the light is entered the particles, there are so many reflections to the height above. So that's why if the blue color is appears to our sky is blue. Why it is not red? Means the red color is larger end wavelength. So that's why the larger end wavelength means it has to be the scattering of light is not absorbed by the red color. That means when it is reflections are very less. So that's why the blue color scattering of light is appear on the sky. When it is observed some such height, we can observe that is a blue color. So that's why we have the color of the sky is blue. So that means the scattering blue light enters our eye. If the earth had no atmosphere, there would not have been any scattering. Then the sky would have looked dark. Why it is look dark means they have any scattering of light is not there. Because of in night times there is no light. So that's why the sky is appear dark. When the light is there, so many scattering of light is there. So that's why we have to appear the sky is blue color. Are you understand? So that's why the sky appears dark to passenger flying at very high altitudes. So that's why a scattering is not prominent at such heights. So you might have observed that danger signal lights are red in color. Do you know why? Because of the red is the least scattering of by fog or smoke. Therefore, it can be seen the same color at a distance. So it appears very bright nature. It has a large wavelength. So if it has large wavelength, less reflection. If it has small wavelength, heavy reflections. So it is clear. So it is directly inversely proportional. That means the scattering of light, the instant of light is inversely proportional to the wavelength. So wavelength is nothing but lambda. Intensity of scattering of light is I. So I is proportional to 1 by lambda. I is proportional to 1 by lambda. So here I is intensity of scattering of light is inversely proportional to 1 by lambda. That means I proportional 1 by lambda. That means inversely proportional. If it is I is increases, lambda is decreases. If I is decreases, lambda is increases. Why the lambda means the lambda power 4 times. That means we have to see in textbook 1.8 times greater than the blue light. Which one? Red light. So red light appears when the blue light is 1.8 times greater than the blue light. So that's why here the I is proportional to 1 by lambda to the power of 4. Are you understand? See here, the intensity of scattering of light is I, wavelength is lambda. So scattering of light is inversely proportional to wavelength. So I proportional to 1 by lambda. So I scattering of light is proportional to 1 by lambda to the power of 4. That means in blue color, it means 1.8 times of greater than the blue light wavelength. That means red light wavelength greater than blue light. So blue light wavelength is very small. Blue light wavelength is very small, and red light wavelength is very large. So that's why the red light appears in the fog or smoke. So it's very clear. So that's why the red light we are using danger signals. Okay. So we can observe the red light signals so far appear very clear and clean. So that's why the red signals are using in danger signals. So this is a scattering of light main concept. Thank you everyone.